So let's start with tutorial 2. So let's draw the diagram and for the AND gate, the problem. Okay, so what's the problem? The problem is develop a Boolean expression for output application. It's very simple. Just use the basic knowledge and okay, we should draw the diagram. Okay, it's an AND gate and there is an OR gate. Okay, for X. Okay, so we have A and it can be prime. Okay, and then we draw the AND gate and then link with the OR gate and the output is X. So we do one by one. First of all, in this AND gate we just use multiplication of C prime and D prime, and then for the second AND gate it's gonna be C D prime B prime, and here it's gonna be A prime into it's A into B prime, and then we OR it, it's gonna be A prime A prime A so A B prime plus C D prime B prime. So it's a very simple. X equals to B prime C D prime plus A B prime. So let's go to number B. So simple. B is more even simpler. It's just two AND gates and added by OR. So let's A prime B. We're gonna get it A B prime, and we have A C D prime all in connected into, and we're gonna be multiplying them, and then we are gonna add them. That's it. A B prime plus A C D prime. So X equals to A B prime plus A C D prime. Okay, so for number 2 question, for the graph, you have to be okay. So let's draw the diagram and then we are gonna find the equation. So this into an NOR gate, and then this is also to an NOR gate. B is connected to the NOR gate with A, and C prime you can say as it's inverted by NOT gate, and then we have NAND gate. So it's a little bit complicated circuit, but we have only thing to do is to do step by step. First we do solve this, and then A plus C prime bar, this is gonna be A plus B bar into A plus C bar into, that's how you should do it. So we got the equation A plus B bar into A plus C bar. So as we know from the De Morgan's law, A into B bar equals to A bar plus B bar. So we are going to do the same here. A plus B bar plus A plus C bar. So it's gonna be just same A plus the double bar cancels each other out. The De Morgan's theorem. Okay, so it's better to know them. There are only two laws, so keep practicing them. So then we will draw a truth table. It's gonna be there are gonna be three outputs A, B, C. It's gonna be 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So anything C prime is 1, so just we will just write everything that 0 is 1. Right, anything A is 1, so we're gonna have 1, 1. So we got 4, 1. Anything B is 1, so we'll have only 1, 0. So right now, let's look at the truth table. So the output is only 0 when um, so we'll just try to track the output when A is 1. If other parts is what do you say, if they are 1, there's no problem. Okay, so A, B have to be draw with the diagram. Be careful with the diagram because B is 1, C you have to be careful while dealing with this type of diagrams because we have to make sure they align. Okay, next for x, for only x is 0 when A is low, B is low, and C is high. So at this direction, this part, this is gonna be low. Sorry, we have to align with it. So that's how. The other part is just gonna be 1 because for every value of x there's 1. You only look at the one that's like rare. For here the value of x is rare, so this is only the part, and for other parts it's gonna be 1, 1, 1. So you have to be careful with aligning with. So let's go to number 3, which is De Morgan's theorem. A plus C into D. Okay, so we used De Morgan's first theorem, which is A prime plus B plus C prime into this bracket and plus D prime, and double bar cancel, so we'll have A bar plus B bar, not B bar, it's gonna be C bar plus D bar. That's it, very simple. Use De Morgan's theorem. Now we have A, B, C, D. It's there. So first of all, since there are two double bars over ABC, so we try to separate them A, B, C, D, and D. A, B, C, this, and this is D prime, and then we are gonna have A, B bar into C plus D prime. So we can do like this: A plus B prime into C plus D prime. Okay, C, A plus B equals to A plus AB, and then you take the common, and this 1 plus B is 1. So you can remove the B, it's gonna be just A. Let's go for number D. AB plus A prime plus B prime into C equals to A B plus use De Morgan's second theorem. We just get A prime B into C. So use another law, which is A plus A prime B equals to A plus B. So we use AB plus C. So we get this. E A B C into AB plus C prime into BC plus AC. Okay, this looks lengthy, but it's not, because C prime will cancel both of these equations. So we'll have AB here, and then AB into ABC equals to ABC. That's the answer. Okay, let's go for number 4 question. Convert the following expression into canonical SOP form. So let's do number A. Let's do number A, which is if A B C equals to A plus C into A B plus AC. Just multiply, just do the multiplication first. AB plus AC, BC plus AC plus AC, which is AC. So AB plus ABC plus AC. So in canonical form, we need to have all the variables. So here, since C is missing, we'll have to add C by using the formula C plus C prime, which is equals to 1. So that's how we got it. ABC plus A AC plus B plus B prime. So just multiply and we'll get our canonical SLP form. ABC plus ABC plus AB prime C. Okay. Okay, so we'll try to take the common ones. We'll cancel. ABC is common. A ABC is a lot. So ABC prime, and then we have A B prime C. So we're left with 3 equations. So let's go for number B. It's if A B C D, it's AB plus CD. It's A B prime plus C D. So we just multiply them, a b prime c d, and that's cd even cd. So what we do is that we continue to multiply with them, c plus c prime, d plus d prime, plus a b prime cd remains. Plus same goes for cd, a plus a prime, b plus b prime. Okay, so a b c, a plus a b c prime into d plus d prime plus a b prime c d plus a c d plus a prime c d into b plus b prime. So a b c d plus a b c d prime plus a b c prime d plus a b c prime d prime plus a b prime c d. So we get a b c d plus a b prime c d, a okay, yeah, sorry, we made a mistake. No, we didn't make a mistake, we forgot to write the bar here. Sorry, sorry. We made a sorry, a b a b c d, and then a b prime c d plus a prime b prime c d. So you have to be careful while doing this math, and we see that a b prime c d is repeating here twice, and others are like they are not repeating. So we have 7 terms, I guess. A B C D, A B C D prime, A B C prime D plus A B C prime D prime. Then you have A B prime C D, which was from before. Then we have A prime B C. So we have A B C D, A prime B C D, A A prime B prime C D. Okay, so let's go to number 4. Find the mean term and max term. Okay, function a prime b is a b c d equals to a prime b prime c prime d prime plus a prime b prime c prime d plus a prime b c d prime plus a prime c d. So it's gonna be product of sum. So for this, we need to do the K-map. K-map is easier, in my opinion, than truth table. See, there's one strategy that I do is to memorize the block numbers because it's easier. So this one thing which I don't recommend, but you guys can get it by calculation. So 8, 12, 1, 5, 9, 13, 2, 6, 10, 14, 3, 7, 11, 15. Okay, so 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we have to look for when the output will be 1. So for this, all of the outputs need to be 0, 0, 0, 0. So it's going to be 1 here. For this, it's going to be 0, 0, 0, 1, 0, 0, 0, 1. So here, and then it's going to be 0, 1, 1, 0. So 0, 1, 1, 1, 0. And here a prime, it's going to be 0, 1, 1, 1. So 0, 1, 1, 1. It's going to be here. So you get it. So if A, B, C, D plus the M0, M1, M6 plus M7, which you can write with the summation sign 0, 1, 6, 7. So they are actually for maximum. Maximum is going to be just the opposite of this. Or not. So not the maximum. They are asking uh, for f prime. The maximum of f prime. So f prime is going to be uh f prime is gonna be the maximum for a prime are the ones that are not included in the table. So for f prime, it's gonna be same. F prime the maximum of f prime are equals to the main term of f function f. So it's gonna be just the summation of 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15. That's it. And let's go. 1 or 5. Okay, so number 5 is the function ABC. So let's write the function ABC. A plus B prime B C prime plus B plus A plus B prime plus C prime plus A prime plus B plus C prime plus A prime plus B prime plus C prime. Okay, so we have to what construct the truth table for this. So it's very easy for drawing a truth table. X A A B C. You need to have 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 0, 1, 0, 1. How many variables? Okay. I need to cross check that I don't miss any variable. Since it's a pure POS, the min terms are the ones that have 0 as output. So POS, if for this has to be, so we'll do manual calculation, but it has to be 0 0 1. So 0 0 1 will have 0, for this 0 1 1, 0 1 1 0, this it's gonna be 1 0 0 1 1 0 1, sorry, 1 0 1 0, for this 0 0, sorry, 1 1 1 0. Okay, so let's try. It's gonna be 1 here, 1 here, 1 here, 1. Anything that's C0, it's gonna be 1. So we got it. So let's try the max term for this. For max term, it's opposite of sum of products. I think I've said mean term, so I made a mistake. M1 max term. Okay, so max term is when the output is 0. Output is 1, sorry, sorry. Output is 0, yeah, for POS. And 5 M7. So that's the max term. You just gather the ones that have been 0, or have been 0. Okay, for mean term, it's the outputs that have been 0 1 1, sorry. So I got confused, so let me clear this out. Max term for POS is when the output is 0, and for mean term it's when the output is 1, and for the sum of product, the mean term uh, should be 1 for SOP, and max term should be 0. I got a little confused, but you guys, I hope you guys understand what I wanted to explain. So it's gonna be easy. Let me explain. Okay, so 6. So we need to use NOR get. NOR gets means you need to get into additional form A, B, C. So we are going to do the double bar, X double bar. So we'll get A double bar plus B double bar plus C double bar X equals to, so which is X A plus B plus C. So we need to draw it using NOR gate. So we have to invert A, B, and C, and then we are going to add them up using another NOR gate. Okay, I hope you guys understand. Let's go for the equation. X plus A plus B plus C bar, which is, okay, so we have to invert A and B. You could directly put C into the equation, or you could have used you could use 3 gates, NOR gates for C, but I think it's gonna be better if I use 1 gate, because 3 gates are like hassle. Why would I want to put 3 gates? So I just want to put C directly into the equation. It's gonna be the same. I don't want to invert it, so let's go for number 3. X equals to a plus b is c plus d. Let's do De Morgan. A plus b a plus sorry plus d. So we do what? X equals to a plus b double bar plus c plus d double bar, which is a plus b plus c plus d. Just do it invert and that's it. We can with a and b is we can do it in this way. So we can do a and b in one diagram and c and d in another diagram. Then we use this for x. Okay, let's do with NAND gate. On NAND gate, it's same x equals to a, b, c. So we just put an inverter. We put the inverter. B we have to use the x equals to a plus b plus c bar. We have to use double bar. So a plus b plus c double bar, which is a in double bar into b double bar plus c triple bar, which is a into b into plus c prime. So you invert it. B you invert C. You don't need to invert. You can directly put it. So you get X and C is like just the multiplication of C. X equals to A plus B C plus D. NAND gates. We are going to have to take the outputs here separately. Here we just because here the reason we are doing is like we want to multiply a prime into b prime into b, and then we have c prime to d prime, and we will have a prime b multiplication of c prime c prime c prime. So let us break this down, which is equals to a uh which will, I think it's, which we can do it in a simpler way, but okay, a into b prime into, sorry, not together, it's separate prime, then c into d prime, and then I can reverse it. We could do it in a simpler way, but a plus b. We could have removed this part and then do it. But okay, since we have done it this way, it's okay. So we are done with tutorial 2.